100 facts about the galaxy. 1. A galaxy is a vast, gravitationally bound system of stars, stellar remnants, interstellar gas, dust, and dark matter. 2. There are estimated to be over 2 trillion galaxies in the observable universe. 3. Our own galaxy, the Milky Way, contains over 100 billion stars and is just one of these countless galaxies. 4. The Andromeda Galaxy, our closest spiral galaxy neighbor, is on a collision course with the Milky Way and will eventually merge with it in about 4.5 billion years. 6. Galaxies are not randomly scattered, but are part of a vast cosmic web-like structure, made up of filaments of dark matter and galaxies. 5. The Hubble Space Telescope's deep field images revealed thousands of galaxies in a tiny, seemingly empty patch of space, illustrating the vastness of the universe. 7. Galaxies come in various shapes and sizes, including spiral galaxies like the Milky Way, elliptical galaxies, irregular galaxies, and dwarf galaxies. 8. **8. Elliptical galaxies are shaped like ellipses and are often devoid of the prominent spiral arms seen in spirals. 9. Irregular galaxies lack a regular shape and can be chaotic in appearance. 10. Many galaxies, including the Milky Way, have supermassive black holes at their centers, with masses millions to billions of times that of our Sun. 11. Active galactic nuclei. Some galaxies have active galactic nuclei powered by the accretion of matter onto supermassive black holes, emitting intense radiation. 12. The Milky Way has 4 major spiral arms: the Scutum Centaurus arm, Sagittarius arm, Perseus arm, and Out arm. 13. Galaxies are not isolated. They often cluster together. The Coma cluster contains over 1,000 galaxies. 14. Smaller collections of galaxies are known as galaxy groups, with our local group containing the Milky Way, Andromeda, and over 50 smaller galaxies. 15. The Small Magellanic Cloud is one of the Milky Way's satellite galaxies, visible in the southern hemisphere. 16. Galaxies often interact and collide, leading to the formation of new galaxies and the alteration of existing ones. 17. Galaxies are hubs of star formation, with massive clouds of gas and dust giving birth to new stars. 18. Galaxies can have multiple stellar populations, including young, hot stars and old, cool stars. 19. Each galaxy is thought to be surrounded by a massive halo of dark matter, an invisible substance that exerts gravitational influence. 20. Observations of galaxy rotation curves provide evidence for the existence of dark matter within galaxies. 21. The gravitational pull of galaxies can bend and magnify light from objects behind them, allowing astronomers to study distant galaxies. 22. Galaxies evolve over time, with mergers, star formation, and other processes shaping their structure and appearance. 23. Some galaxies are extremely dim and spread out, known as ultra-diffuse galaxies, challenging our understanding of galaxy formation. 24. Quasars are extremely luminous and distant objects powered by supermassive black holes. They are among the brightest objects in the universe. 25. Interactions between galaxies can result in the formation of tidal tails, long streams of stars and gas pulled away by gravitational forces. 26. Galaxies often align along cosmic filaments, forming superclusters of galaxies. 27. The color of a galaxy can reveal information about its age and star formation history. 28. The redshift of a galaxy's light is a measure of its recession velocity due to the expansion of the universe, as described by Hubble's law. 29. Some galaxies, known as starburst galaxies, undergo rapid and intense periods of star formation. 30. Barred galaxies have a central bar-shaped structure, in addition to spiral arms. 31. Regions of intense star formation in galaxies are often associated with nebulae, like the Orion Nebula in our Milky Way. 32. The CMB is the remnant radiation from the Big Bang and provides a snapshot of the universe's early state. 33. In galaxy interactions and mergers, smaller galaxies can be cannibalized by larger ones. 34. Computer simulations help scientists model and understand the formation and evolution of galaxies. 35. Dwarf galaxies are smaller than typical galaxies and can be found in abundance around larger ones. 36. Globular clusters are dense, spherical groups of stars often found orbiting galaxies, including the Milky Way. 37. The local void is a vast region in space, largely devoid of galaxies, located near the Milky Way. 38. Large-scale sky surveys, like the Sloan Digital Sky Survey, SDSS, have catalogued millions of galaxies. 39. Over cosmic time, galaxies collide and merge, leading to larger, more massive galaxies. 40. Colliding galaxies can produce gravitational waves, ripples in spacetime, detected by instruments like LIGO and Virgo. 41. These galaxies are small and intensely blue due to ongoing star formation. 42. Galaxies can expel gas and dust in powerful outflows, known as galactic winds. 43. Galaxies vary in size, with some dwarf galaxies containing just a few million stars, while others contain trillions. 44. Larger galaxies can eat smaller ones by pulling them apart through tidal forces. 45. Some galaxies have smaller satellite galaxies orbiting them, like the Milky Way's Magellanic Clouds. 46. Galaxies' shapes are influenced by factors like their angular momentum and the presence of dark matter. 47. AGN emit powerful radiation due to the accretion of matter onto supermassive black holes at their centers. 48. Galaxies are surrounded by halos of dark matter, extending far beyond their visible components. 49. Elliptical galaxies vary in size from small, compact ones to massive giants. 50. Galaxies tend to cluster together, forming groups, clusters, and superclusters separated by vast cosmic voids. 51. Galaxies can transform over time, changing from spiral to elliptical, or vice versa. 52. In addition to Andromeda, other Milky Way neighbor galaxies include the Triangulum Galaxy M33 and the Large and Small Magellanic Clouds. 53. The study of galaxies relies on data from various wavelengths, including visible light, radio waves, infrared, and X-rays. 54. Observing distant galaxies allows astronomers to look back in time and study the universe's earlier stages. 55. This massive galaxy cluster is known for its strong gravitational lensing effect. 56. These galaxies have irregular shapes and are relatively small, often with ongoing star formation. 57. Stars within galaxies follow elliptical or nearly circular orbits around the galactic center. 58. The presence of galaxies can influence the distribution of dark matter in the cosmic web. 59. These small, faint galaxies often lack significant ongoing star formation. 60. Scientists study the life cycles of galaxies, from their formation to eventual transformation or merging. 61. Some spiral galaxies have a red hue, due to the dominance of older, cooler stars. 62. Supermassive black holes in galactic centers can grow through accretion, leading to AG inactivity. 63. The local void, near the Milky Way, has a diameter of around 150 million light-years. 64. LIGs emit most of their energy in the infrared part of the electromagnetic spectrum, often due to intense star formation. 65. The IgM is the sparse, ionized gas between galaxies, and it's a crucial component of cosmic structure. 66. These small elliptical galaxies often have low star-forming activity. 67. Spiral arms in galaxies are not physical structures, but rather density waves that move stars and gas. 68. These small groups contain just a few galaxies in close proximity. 69. The CGM are the gas and dust surrounding galaxies, and it plays a role in galaxy evolution. 70. The location within a galaxy can impact a star system's habitability due to factors like radiation and metallicity. 71. Some dwarf galaxies are considered fossils from the early universe, preserving its conditions. 72. Compact. Massive galaxies from the early universe are known as red nuggets due to their color. 73. The Magellanic Stream is a long ribbon of gas, pulled from the Magellanic Clouds by the Milky Way's gravity. 74. Distant. Faint blue galaxies are some of the universe's earliest galaxies, dating back to just a few 100 million years after the Big Bang. 75. Superclusters are some of the largest known structures in the universe, consisting of multiple galaxy clusters. 76. Bars in spiral galaxies often form due to the gravitational interactions between stars and gas. 77. Early galaxies in the universe are known as protogalaxies, forming from primordial gas clouds. 78. Some galaxies cease forming new stars in a process known as quenching, often due to their gas being depleted. 79. Galaxy mergers can trigger intense starbursts, as gas is funneled into the galactic center. 80. Stars in galaxies produce and release heavy elements, influencing the chemical composition of the universe. 81. The central, bulging regions of galaxies are often dominated by older stars. 82. Some galaxies exhibit a warp in their disks, where the disk is not perfectly flat but bends. 83. This galaxy, part of our local group, has a relatively low metallicity and ongoing star formation. 84. Close encounters between galaxies, known as flybys, can alter their shapes and orbits. 85. Some galaxies reside in the cosmic voids, regions with low galaxy density. 86. A galaxy's environment can influence its star formation rate, shape, and interactions. 87. The Milky Way's halo contains old, metal-poor stars, often in globular clusters. 88. The study of galaxy dynamics reveals the mass distribution and dark matter content of galaxies. 89. Galaxies can eject gas in outflows, affecting their chemical evolution. 90. Interactions with nearby galaxies can subject a galaxy to tidal forces, leading to deformations. 91. The galaxy M87 hosts a prominent jet of relativistic particles powered by a supermassive black hole. 92. Bars in galaxies can funnel gas toward the center, triggering star formation. 93. The Oort cloud is a hypothetical region in the Milky Way containing icy objects and comets. 94. *** 94. Galactic magnetic fields. *** Magnetic fields permeate galaxies, influencing cosmic ray propagation and star formation. 95. Symbiotic star systems in galaxies feature a white dwarf and a red giant. 96. Star clusters within galaxies come in two types: open clusters, young stars, and globular clusters, old stars. 97. The thickness of a galaxy's disk can vary, with thicker disks often hosting older stars. 98. The chemical composition of stars in a galaxy can serve as a fingerprint of its history and evolution. 99. Galaxy interactions can affect a star system's habitability by altering orbits and environments. 100. The processes within galaxies, such as supernovae and black hole activity, can provide feedback that influences their evolution and the surrounding intergalactic medium.